A nice video for this introduction. So before starting my talk, I would like to thank the organizers of this interesting scientific day conference, especially the University of Jakarta. It's not the first time I'll be with you. I'm with you and the rector, the organizing committee of this version of Science and Mathematics International Conference. I would like also to especially thank Dr. Mutia Delina for her kind cooperation as usual. Thank you very much.
Thank you, merci beaucoup.
So it's a great pleasure to be with you today to present a computer science topic related to prediction techniques in during the period of COVID-19. And via this talk, I will present our work concerning predicting the number of firemen operations during the COVID-19 period in France. So here is the outline of my talk. I will start with an introduction. What are the main operations of firemen in France, especially during the COVID-19 period, and what are the data set? I'll show you the data set that we use in our experiments, in our study, the preparation, and the intervention and prediction, and I will end by a conclusion and some future directions. So, to start, the World Health Organization recorded the first pneumonia of unknown cause on December 31, 2019 in Wuhan, China. A few days later, on January 24, 2020, it was confirmed that the virus has reached France. So countries could never have imagined that such a devastating viral disease would emerge and a pandemic can cause morbidity around the world. The ability of public health actors, populations, and institutions to prepare and answer the challenges of such crisis in order to maintain essential functions was not satisfied in the whole world, worldwide. So during this pandemic, as well as all we know, hospitals faced bed shortages, delayed of non-urgent surgeries, and the mobilization of all medical staff resources. So this had a direct impact on the fire and rescue services in France, which they are the first actors of aid and emergency care provided in the operational response in this pandemic. So yes, as I said, healthcare facility preparedness is a key component of the response to the COVID-19 pandemic, and it was crucial to ensure appropriate space, supplies, and personnel, prioritizing care, activating triage procedures, and training staff on infection prevention, control, and clinical management of COVID-19. So in France, firemen were the key players in this crisis, in caring for people and in supporting the health system by participating in transports between hospitals by land or even by helicopter. They also run facilities for the elderly, like examination, disinfection, distribution of meals, etc. Then, and over that time, the number of firefighters' interventions has steadily increased, reaching more than 5 million operations during the COVID-19 period. So the calls out over time, firefighters call out have increased, where they have been on the front lines fighting the coronavirus pandemic for the past 2 years. Therefore, the use of artificial intelligence or new machine learning or deep learning techniques was possible to predict the number of firefighters' missions, which can directly lead to relief and better control of financial, material, and human resources by estimating the possible flow of interventions, for example, for next hours or for next days, and even for next months. So such forecasting or prediction can improve the efficiency of emergency operations while reducing financial operation costs. So with my PhD student, our objective in this study with the collaboration with the fireman direction here was to learn and apply machine learning techniques to tailor the need for firemen operations to their demands. So this strategy enables fire departments to organize their resources, which, as I said, leads to a reduction in human, material, and financial requirements. So we focused on this study on predicting the number of firefighters interventions during this sensitive period of the global pandemic COVID-19 using machine learning. So maybe you have a computer science background, or you know a little bit about artificial intelligence and machine learning. Most of AI research focuses on solving real-world societal problems such as health services, you can find in economy, in education, finance, agriculture, and more domains. So the process begins with integrating a particular piece of information, data, analyzing data sets, and obtaining results, and using those insights or the results to improve decision-making and life outcomes. These are the objective of artificial intelligence. And machine learning, which is an application of artificial intelligence, is the current revolution that is emerging these days with deep learning techniques, and will affect life in almost every field. So, and especially AI and more precisely machine learning have played an important role in healthcare research during the COVID-19 period. These techniques allow computers to interpret large amounts of data to quickly identify patterns and insights and understand the pathobiology of this disease. So during this period, numerous studies have been proposed in various countries, and especially to predict the spread of COVID-19. For example, machine learning helped detect COVID-19 at an early stage, which helped monitor disease progression and potentially reduce mortality. So if you want, I just have two slides maybe to show you how machine learning works before I start how we use it for fireman prediction. So machine learning, as I said, is a form of artificial intelligence techniques that teaches computers. We had computers to learn to think in a similar way to how humans do. So learning and improving upon past experience, we have a data set, we learn, and we teach computers. It works by exploring data and identifying patterns, and involves minimal human intervention. So any task that can be completed with a data-defined pattern or set of rules can be automated with machine learning. So as I said, it is used in several domains and enterprises, and nowadays companies are increasingly using machine learning algorithms and deep learning algorithms to make things easier. For machine learning, we have, just quickly, we have two categories of machine learning techniques. The supervised learning, or the supervised machine learning techniques, which is an approach that's defined by its use of labeled data set. So the data set is labeled. We need some human intervention. These data sets are designed to train supervised algorithm into classifying data or predicting outcomes accurately. So using labeled inputs and outputs, the model can measure its accuracy and learn over time. So supervised learning can be separated into two types: classification and regression. We have several existing machine learning techniques for classification and regression. Here for classification, we can see we have support vector machine, naive Bayes, nearest neighbor, or neural networks. For regression, we can see we have linear regression, decisions trees, neural networks, etc. And the second category of machine learning techniques are unsupervised learning. So here we have less human interventions. We use machine learning to analyze and cluster unlabeled data, so data sets, so don't have labeled data. So this algorithm discover hidden patterns in data without the need of human intervention. So hence they are unsupervised. So these models are used for three main tasks: for clustering, association, and dimensionality reduction. We can find k-means, k-modulus, hierarchical, unsupervised learning, neural networks, and etc. So, as I told you, to use machine learning techniques, we need data sets. We need data to teach computers. For predicting the interventions of firefighters or firemen interventions, we need some data set. We need to teach. We need to learn from previous experience in order to predict the future. So the data set we use in collaboration with the fireman departments that we use in our study, as you can see here in this figure. It was provided by the Fire and Rescue Department in the Doubs region in France. Okay, it contains hourly recorded operations from 2015 to June 2021. The hourly data set consists of more than 50,000 interventions. The aim of, or the objective of our study was to predict the number of firefighters by performing several steps. You know, when you have a data set, it's a gross data set, as I can say that. We need to prepare the data. We need to clean the data and prepare it to be used by computers and by machine learning. So we performed several steps before applying or for intervention prediction, starting with the reduction of the number of features. We have a lot of high number of features. The detection of the breakpoints related to the coronavirus to detect where was the peak of coronavirus pandemic, the comparison of the selected features before and after the COVID-19, and finally the detection of the anomalies in the data set. I'll explain each step. So first, to prepare the data, the first step is feature selection. So the data set of the region of Doubs in France that we got contains more than 1,500 attributes, which complicates the processing of the data. Therefore, a feature selection phase is required before we proceed to the next stage of the study. So the idea is to retain only useful and important features in the data set by removing irrelevant attributes. So a feature is considered irrelevant if it has been removed without affecting the performance of the model. It's also called feature importance. You know a little about that. You can call it also feature importance. It's a built-in class where a score is assigned to each feature in the data set. And the higher the score, the more relevant the feature is. So in our work, we used 3 machine learning algorithms, XGBoost, extra tree classifier, and random forest regressor. For each algorithm, feature importance of feature selection was calculated, and the common best top 16 attributes were extracted, including, for sure, the lockdown features corresponding to the period of COVID-19. So at this stage, feature selection gets significant results. We compared, and the root mean square error decreased. When we decreased the number of attributes, the error decreased also from 2.1 to 1.4. And also the training time of the model was reduced. You know, if we have more than 1,000 features, it's not like we have just 16 attributes or 16 features without affecting the accuracy of the model. So mainly we divided the time by 10. Another step was the breakpoint detection. So in the data set you use, it's quite obvious to recognize an increase in the number of fireman interventions starting in August 2020, which is closely related to the augmentation in the number of COVID-19 cases in France. As we can see here in this figure, which shows the number of active cases since the emergence of coronavirus disease in France until today. Thus, the objective of change point detection is to highlight the direct impact of coronavirus on the number of firefighters interventions. For this purpose, to find this breakpoint, we use a Python library for the analysis of breakpoints called Raptor. If you know it, was applied. After running the code, a change point was detected on August 5, 2020. And it is presented in here, in the green dots. It's in this figure. So we divided our data set into 2 subsets, before and after, or pre and post COVID-19 spread. Further action was taken also by rechecking the order of features importance to ensure that the attributes related to the COVID-19 differed if they were before or after the breakpoint found. So here in this table that I show you here, confinement 1, it means that lockdown 1, and lockdown 2 for confinement 2, and couvre-feu means curfew, respectively. So here I show you so before and after breakpoint associated with the coronavirus, and you see the feature importance score of these attributes. So we should take these attributes into consideration in the feature or in the feature importance, and after in the intervention detection. So the goals, while the goals of the lockdown and curfew may seem similar, there's a major difference between the two. During a curfew, where people are forced to stay at home for a specific number of hours, and major services remain closed for a certain period of time. So here for breakpoint detection and the separation of the data sets. So here, besides, I will show you the attributes, the feature selection before and after. So it's highly suggestive that the breakpoint discovered on August 5 is directly related to the rise in COVID-19 cases in France, which has led to a significant increase in the number of firefighters interventions. So this peak was reached nearly 3 months after the initial lockdown, the first lockdown, the confinement 1. When the virus began to attack the younger generation. So in this step of analysis, as you see here in the figure, the feature selection method was replicated in order to see the difference between the feature importance. And we can see after the coronavirus, we have more feature importance related to COVID-19. We can see in this feature the lockdown, the curfew, which are related. So after the breakpoint, just here the two figures to show you that the attributes, the feature importance, changed in the same data set, and we start finding feature importance related to COVID-19. After that, we have the anomalies detection. So it's required in such huge metadata to find elements that trigger suspicious that might be different from the majority of the data. So logically, these anomalies can be associated with rare events, such as water floods, large fires, power outages, and of course, COVID-19 disease. So in our work, isolation forest, which is an advanced statistical learning technique, was used by importing the PyCaret library. And this method assumes that some data points are more dominant than others, making outliers eligible to the isolation mechanism. So anomaly detection was done by selecting a random subset of data. Then the threshold value is assigned, lower and upper threshold, any value in the minimum and maximum range of the selected features. So after that, if the value of the data point is less than the threshold, the selected data point moves to the left branch. The steps are repeated until the maximum value, the maximum depth and value is reached, or isolation is assigned. So isolate anomaly from normal data. So here the anomalies are represented in this figure by the red points. And we can see here is the period of COVID-19, and we can see how there are the largest number of anomalies during this period. Now for intervention prediction, after preparing the data, after doing these several steps, 2 experiments were performed on the data set after applying all the above steps. So the first experiment aimed to predict the number of firemen intervention for any period or date. This required replacing the detected anomalies with the mean of the non-outlier values. Then the breakpoint was recalculated to test if the changes influenced the selection of the coronavirus period as the point of change in the data set as we did previously. And finally, the interventions for the period before and after the peak are predicted. On the other hand, the second experiment predicts the values considered abnormal by replacing the normal data points with their mean. So the idea behind this is to test the efficiency of the proposed model, of our model, in predicting an abnormal value that is certain to deviate from the normal trend, particularly during the coronavirus pandemic. So here, quickly, the data set after replacing the detected anomalies with the mean of the non-outlier values. So here, data set after replacing the anomaly. So, and after recalculation, the breakpoint of the breakpoint, and after removing the anomaly, the breakpoint as presented in green dots was recalculated here, as you can see here in the figure, in order to find the coronavirus period in the data set and divided it to pre and post COVID-19 after all this data preparation to test if the changes influence the selection of the coronavirus. But we verified that it's impossible to ignore the period of coronavirus, and the data were clearly appeared in the experiments, as you can see here for this period. So 2 major events were identified in our work: a breakpoint associated with the COVID-19 period and anomalies found throughout the data set. So the anomalies were replaced with the mean of the values, as I said, that were not outliers. And then the breakpoint was recalculated. This is shown in the previous, as I showed in the previous figure, which also contrasts the predicted values with the actual values. So again, in our study, the data set was mainly divided into 2 subsets, as I told you before. So before and after the August inflection point, where the intensive spread of COVID-19 in France starts. So in this figure, we show the before the pre-COVID-19 peak and post COVID-19. And both data sets was retrained after replacing the anomaly to check the actual versus predicted values of the fireman intervention. So it was important to predict not only the normal value after the anomalies was removed, but also the anomalies themselves for the years from 2015 to 2021. So here I'll show you the accuracy of our model. So in addition to check how accurate the prediction is for the test set, the period before August 5, 2020, and the period after August 5, 2020. So the mean absolute error and root mean square error metrics were used as indicated here in the figure, and you can see how our model was able to predict for the testing set. It was able to detect the intervention of firemen in the regions with good accuracy. So on the other hand, the second experiment predicts the values considered abnormal, as shown here in this figure, by replacing the normal data point with their mean. So the idea behind this is to test the efficiency of our model in predicting an abnormal value, what is certain to deviate from the normal trend, particularly during the coronavirus pandemic. So a further step to improve the model accuracy is to classify the fireman interventions into normal and abnormal value. After detecting more than 1,000 anomalies and replacing them with the mean of non-outlier value, better prediction was achieved for the entire data set and for both the pre and post COVID-19 periods. And on top of this, the most important result is that after applying modifications to the data set, the breakpoint always remains the same. So that even by replacing all anomalies, the COVID-19 period was always detected and in our model, and it's a matter of great concern to verify the predictive accuracy of the intervention classified as abnormal. So after replacing the anomalies with the mean of normal values, the results of the errors was 0.7. And these results are very prosperous. So now to conclude my talks, as I showed you, the objective was to show the study we did in order to predict the number of time firefighters are called after detecting a breakpoint associated with the COVID-19 pandemic. The first step was to select important features by applying the feature importance method. Then the breakpoint was detected, and last anomalies were replaced in the data set. In each step, the prediction of fireman interventions was performed using the XGBoost algorithm. We tested with this algorithm. Maybe we can use and compare with other algorithms. So the results show promising accuracy in predicting regular or irregular during normal period and during, for example, COVID-19 pandemic can predict the fireman intervention. So just actually my PhD student is working on prediction of the number of firefighters missions by intervention type to predict each type of the intervention, and it will be implemented soon. As well, other machine learning techniques will be used to optimize the accuracy of our proposed model. Okay, so thank you for your attention. I hope it was interesting. And if you have any question, I'm ready to answer. Thank you.
Thank you, Prof. Abdullah. It's very interesting research actually, yeah, to predict the number of fireman intervention during the COVID-19 pandemic. This is the most one important in your research. Is there any question from the audience, please? Okay. Yeah. Honey.
Okay, hello from Abdallah.
Hello.
I'm Hani from Physics Education Part of University State Jakarta.
I can't hear well because there's
Hello.
maybe you can mute your phone, your microphone if you are not.
Hello. Hello.
Yes. Hello.
Yeah, okay. My name is Hani from Physics Education Part of UNJ, University State of Jakarta. I want to ask, is machine learning can be applied in education? Thank you.
Yes, as I said before, artificial intelligence and especially machine learning or deep learning can be used in several domains right now, in education, in companies, etc. For example, one application was to predict the stress period of students during an academic year. You can see, for example, during the exams period where the stress of students was very high.
Interesting.
Yes, and there's some pedagogic learning to learn the influence or the impact of some pedagogic methods or learning or teaching methods on the results of the students.
Honey, how about the answer?
Okay, thank you.
Thank you.
Okay, we have 1 more minute for the question and answer. Is there any other question from the audience? I have a question of Abdallah. So, in the future, your program will be conducted for the firefighter department?
Yes.
Yes, and it will be predict the human research need for to solve the problem of fire in France.
Yes, our model was tested to predict the fireman interventions, and for example, for next days or next weeks or next months, so that the department can program, for example, the fireman schedule and the presence at the department, etc., according to this prediction, to better schedule and for better organization.
Yes, for better schedule and organization. Interesting. But Hani, maybe most interesting with the stress prediction, I guess. Okay, from Abdallah, thank you for your presentation. It's really interesting, and we would like to thank you for your participation in this fine occasion, and we would like to give you the certificate of appreciation.
Thank you very much. I thank you for this invitation. It's always a pleasure to be with you, to give you seminars.
Yes, thank you. It's my pleasure for all of us too. We would like to send you the certificate virtually. Would you like to close the share screen for a while?
Okay.
The share screen. Yes. We would like to share the certificate to you. Yeah, okay.
It's okay?
Yes. Wait a second. So this is the certificate. Thank you, Prof. Abdallah, for your presentation today. We hope that we will have another collaboration in the future from
Yes,
friends in Jakarta.
hope soon. Thank you very much. Thank you for the invitation, for the certificate.
Yes,
Thank you.
we would like to take a picture together then. Bapak Ibu, would you like to turn on your camera, please? Okay, with on my comment, please give your best smile. Open your smile, please. Okay, 1, 2, 3, and smile. Yeah. Thank you, Prof. Abdullah. Thank you for today.
Thank you very much.
Yeah, I hope we can meet in another event then.
Okay, sure.
Okay.
Thank
So,
you very much.
yeah, au revoir.
Have a nice day. Au revoir.
Have a nice day to you too. Thank you, Prof. Abdallah. Bye-bye. And we are going to continue with the parallel session in room 12. The first one will going to Bapak Eko Setio Purwanto. Bapak Eko, are you ready with your presentation?
Okay,
Yeah.
good afternoon,
Good
Bu Mutia.
afternoon. Yes.
Sorry, okay.
Never mind. But please, would you like to rename your what is it, screen name to be the ABS and then your number, and after that followed by your name.
Okay, I see.
Yeah. For example, for Pak Eko, ABS 5, and then Eko Setio Purwanto.
Okay.
It will be helpful for me, so I can find you easily.
Okay.
Okay, your time to presentation is 10 minutes, and then we will have 5-minute question and answer. Okay, the time is yours, Pak Eko.
Okay. Thank you, Bu Mutia. Okay. So I will see the screen, or I will present for a live session or this video.
Hello everyone,
Ah,
I'm Eko
okay.
from Yunus University. Nice to meet you at this conference. In this opportunity, I will present our paper entitled My Track Map Web-Based Application for Tracking Employees. In this presentation, there will be 4 outlines, namely introduction, method, result and discussion, and the last one is conclusion. Let's take a look. Nowadays, the development of technology that combines things and the internet is very useful. That combination makes our life easier. This technology can optimize the tasks that exist in the current era. Maps provide information about location, but many things have changed since the world stepped on Industry 4.0. And the use of maps has grown rapidly. One of the large geographic information system, or GIS, companies in the world, Esri, has developed an application for mapping known as ArcGIS. ArcGIS is a geospatial software to view, edit, manage, and analyze geographic data. One of the biggest tasks that can be solved using map features is the traveling salesman problems, or TSP, which can be seen in the logistic industry. The problem of TSP is to find the shortest possible routes that visit every city exactly once and return to the starting point or the next destination. The demand for e-commerce logistics is increasing at the same time that e-commerce is expanding. It's crucial connection in delivering tangible goods from producer or distributor to customers. In this previous research, ArcGIS can be used for many cases like decision support tools, spatial analysis, imagery, and remote sensing. Data collection and management, and some research explains that TSP problem can be solved using ArcGIS. Traffic congestion is a major result of the numerous automobiles on the roads. Naturally, this will cause delays in the delivery of goods and people's travel between locations. The main factors that affect congestion are the number of vehicles, the road environment, the ability of the driver, road condition, vehicle flows, and intersections, which are one of the main causes of increasing congestion on roads and become one of the traveling salesman problems or TSP. The main problem in this company, Esri, is that there is no tracking process for sales employees working outside. On the other hand, the manual tracking process is also a concern. To overcome these problems, the simple way is to avoid jams in urban area by looking for alternative routes to reach our goals. In this research, we want to solve the problem that has explained before. We will create a web-based application to track the salesman routes and combine it with ArcGIS. ArcGIS one supports some dataset format like CSV, KML, GeoRS, and GeoJSON. We will use the GeoJSON and GeoRSS to send the data to ArcGIS Online and implement it with our application. GeoJSON is a JSON-based format that permits the storing and transferring of geospatial data. In the meantime, a connection map application can display geospatial data and feature regularly using the GeoRSS format. We also use the ArcGIS API for JavaScript and ArcGIS Developer. With Esri ArcGIS API for JavaScript, we can use to interact the application we develop. To access this JavaScript API, we need an API that can be obtained for ArcGIS Developer and required account authentication. We can access it because we have created a public account. In this study, we will develop a web-based application to track the salesman route called as MyTrackMap. The programming language we use is PHP with Laravel Framework 8 version in complement with Tailwind CSS, and for the wireframe, we use Figma. For the wireframe, as shown in Figure 1, we use Figma, and the ART can be seen in Figure 2. We use the Pontianak City, West Kalimantan, Indonesia, data portal to access the dataset that we are using. There are several datasets available from this portal can be used. However, they are incomplete because the application we are building needs coordinates in the form of longitude and latitude. When we implement the JavaScript API into the HTML or our web application, there are two things we must enter. The first one is ArcGIS script link and CSS. Because some of these classes are more frequently used than others, because the derived classes from this primary class are just given a guide without examples. There are multiple pages in the Esri documentation that explain the subject of JavaScript classes. This must be considered while writing JavaScript code that can designate a point the circle center and define an area with a circle-like form. The circle class is a derivation of the widely used polygon class. The class locators is frequently used a geocoding in the Esri documentation, displaying an address coordinates as longitude and latitude, X and Y. However, this locator has restriction including 100 character limits on address character and an inconsistent address format. The administrator will use the web-based application to give assignment regarding which destination will be visited by the salesman. On the dashboard, there is an ArcGIS map implemented through the JavaScript API. Maps will help keep track of the location salesman has visited over a specific period. To assign a task to salesman, this will be set on the task pairing web page. On this page, we will be given the employee's role option to select the employee roles and destination business to select the destination business category. As we can see in Figure 3, and in Figure 4, the previous standby list will be saved by pressing the Save button if the job create is certain. If the task rate is definite, we simply press the add button to enter the standby list before sending the task to each destination employee. After saving, a message starting task has been successfully sent will appear, and then indicating that the assignment has been successfully delivered to the specific salesman, as we can see in figure 5. And after being given the task by administrator or admin, the application appearance from Sulaiman as a salesman will look like in figure 6. After that, the salesman will immediately carry out the task. If the salesman has arrived at the destination, the application display will look like in figure 6 left, and there is a check-in button. Meanwhile, if the place visit by salesman is not assigned place, the check-in button will not appear as shown in figure 6 right. On the other hand, if the salesman is still outside the minimum distance from the assigned destination, then the salesman will not be able to check in, as we can see in figure 7 left. And now we are moved to the conclusion. The conclusion of this paper as follows: ArcGIS will search for the address based on the value supplied when we enter the address we are looking for. But most of them may be lost because the address format is unclear. And in our opinion, this is due to locator preference for the English address format over the Indonesian address we want. Although we have tested a few different options, the outcomes are considerably worse than those the JavaScript locator. As a result, we will continue to use the locator from the JavaScript API of Esri. However, we are also setting up a technique called reverse geocoding that will allow us to acquire the address and coordinates we need each time we click a spot on the ArcGIS maps. In this manner, user can still search for the target location using their reasoning even if the locator doesn't function as planned. That's all of our presentation. Thanks for your attention. See you.
Thank you very much, Pak Eko Prasetyo. Pak Eko Steel, would you like to turn on your camera? Is there any question from the audiences? Bu Diana, do you have any question?
Yes, as a matter, in fact, I do have a questions regarding to the item or the products when it is been carried out. The port that the salesman goes to before they meet the customer, is it being recorded into this application?
Okay, can I answer it, Bu Mutia? Okay, thank you for the question, Bu Diana. So basically, we can we as a admin, as an admin, we can see the salesman using the maps that's provided by the website.
Yeah, because you know, the Borneo Island is a very vast area, and it includes the land and many long rivers, and then not to mention of the forest also. So you could easily get out of track by your application if you do not include the port where the salesman maybe just taking a break sometimes before they deliver the goods or the item.
Okay. Yeah. Thank you.
That's just our suggestions.
Okay.
For your next future research.
Okay, thank you, Bu Diana, for the advice.
Thank you, Bu Diana, and thank you, Pak Eko. We run out the time, so we have to move on to the second presenter. Thank you for your presentation as well as the response for the question.
Okay,
Thank
thank you,
Pak
Bu
Eko.
Mutia.
Yeah, everybody, we are going to forward to the second presenter, Mr. Alfian, ABS 17, and the title is Algorithm for Finding the Smallest Mean Square Error in Exponential Smoothing Method for the Time Series and Forecasting. Okay, we're going to play the video.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this event, in the Science and Mathematics International Conference 2022, I will present our paper with the title An Algorithm Finding the Smallest Mean Square Error, MSE, in the Exponential Smoothing Method for Forecasting Time Series Data. For introduction, activity forecasting uses information from the past data of a variable or a set of variables to estimate its value in the future. An estimate conducted with the method sees pattern from the past data. The pattern will usually be repeated or relative to the data pattern for the future count. According to Makridakis, there are four types of pattern. There are four types of data pattern, especially time series data, namely horizontal pattern, trend pattern, seasonal pattern, and cyclical pattern. The exponential smoothing method can be used to handle case with the above data pattern. And one of the measurements for evaluating time series forecasting performance is the mean square error, or the MSA. After that, it will be proposed an algorithm to find the smallest value of MSA. Methods for forecasting data time series, the exponential smoothing method use some factors or parameters smoothing. There are three types of factor, where alpha is the data smoothing horizontal factor. The value of alpha between 0 and 1. After that, gamma is the trend smoothing factor. Same with alpha, the value of gamma between 0 until 1. And beta is the seasonal change smoothing factor. The value of beta between 0 until 1. Reviewed from smoothing parameter for predict data pattern, exponential smoothing method become three methods. That is single exponential smoothing method, double exponential smoothing method, and triple exponential smoothing method. And this paper, the study only focused on the calculation of defined mean square error, MSA, with the formula MSA equal to 1 to n, sum from t equal to 0 until t equal to n, yt minus y hat t square. With the information where MSE is the mean square error, n is the number of sample, yt is the actual value of time series data at time t, Y hat t is the forecasting value of data time series at time t. In this paper, we just focus in the TIT method, that is the triple exponential smoothing method. The triple exponential smoothing method use 3 components as parameter to describe the horizontal trend and seasonal pattern. We can see in the reference Makridakis horizontal pattern smoothing with the formula like this, smoothing trend pattern, the formula like this, seasonal pattern smoothing, the formula like this, and the forecasting Ft plus M equal to St plus Bt times M. But the information you can see, and I skip it. After that, we use the actual data. We have 24 data, and we use exponential triple exponential method to do forecast. And after that, we use algorithm using R to generate possible value of alpha, beta, and gamma. And we can see the distribution of mean square error, and we can see the smallest value of mean square error happening between 200 and 400, and according to algorithm, we get the minimum MSE value is 775.076 at the 262 combination. So if we use a modular function 262, we can get E equal to 4, G equal to 3, and K equal to 1. And we apply alpha 0 plus I times 0.1, we get 0.4, and beta we get 0.3, and gamma we get 0.1. Conclusion. On this research, we get several conclusions as follows. For forecasting the above data, especially this using the triple exponential smoothing method, highly recommended to choose the smoothing coefficient, namely alpha equal to 0.4 to capture horizontal pattern, beta equal to 0.3 to capture seasonal pattern, and gamma equal to 0.1 to capture trend pattern, so that obtain smallest MSE value as 729 available combination of alpha, beta, and gamma. Distinct This thing could influence hope for facing risk law when to do sell by shares on the Indonesian Stock Exchange. In this paper, because of limitation in time and power thing. The writer has not yet done creating script with R program language into do search for the smallest MSA value. So the algorithm and programming language used in the Pascal programming language like this. Yeah, I do listing program using Pascal, and like this, if we have
Thank you. It's an interesting and tough presentation, Pak Alfian, actually.
okay.
Is there any question from all of you, Bapak dan Ibu? I have a question for you. What is the application of your theory in daily activity, actually, where we can use this one?
Yeah, the application of this algorithm is the simple application is to do forecasting for someone interested in share or stock exchange. You know, stock exchange.
Yes, forex exchange, marketing as well.
Marketing as well. Yeah.
Yeah.
All data about time series data.
Okay, so you can use the data from the marketing and to find, for example, the trend of the selling or the trading.
Yeah. If we interested in trading, we can use this method.
Okay, thank you. Interesting. Is there any other question, Bapak Ibu? No more question. Then thank you, Pak Alfian.
Okay, thank you.
Yeah, good luck then. Bapak dan Ibu, we would like to continue to the third presenter. The third presenter is Ibu Irawati Dewi Syahwir for ABS 22 with the entitled Integration Smart Cell with Kilowatt Hours Meter. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Hello, introduce my name is Irawati Dewi Syahwir. I'm from Academy of Metrology and Instrumentation, Minister of Trade. I will present my research about integration small scale with the kilowatt meter. Based on the Minister of Trade Regulation number 26 at 2017 concerning legal metrology supervision. Supervision is a series of activities to ensure that the weighing measures and the equipment, packaged goods, and the unit of the measure are by accordance with the provision of the regulation. Supervisory is essential to ensure that a weighing measure and the equipment in circulation comply with the requirements stipulated by the technical terms and are maintained in their use so that losses violation can be minimized. And losses may occur due to violation can be prevented. The government guarantees the correctness of the measuring instrument. Electricity provider and the government have their respective method to protecting their circulating kilowatt meters. But in this case, the system between the two parts is still running individually, and there is no integrated platform between the electricity provider and the government is carrying out the function, the supervision, and protect against kilowatt meters, so that when a violation occurs is still conventional. The system designed based on Internet of Things. This was developed for previous research on GSM-based seal with several improvements, such as the creation of the special database to handle data sent so that it can be stored and visualized as desired, as well as the use of the single model to acquire data and send it to the server via internet. Thus, to integrate it to the two prototype, a cloud service was created that allows for two-way communication, making cloud service integration is best web-based application using PHP framework. A good PHP framework has at least an MVC model, view controller, architecture, and has functions such as database access, session management, and security. Between the web-based application and prototype, an AP application programming interface service will be created as a communication bridge between the two prototypes that can be accessed by integration kilowatt-hour meter and smart seal. The final result of the kilowatt-hour meters processing data that has been acquired and sent to the server can be accessed by electricity provider, government, and consumer in a website application can be accessed online. Smart Seal integration with the electronic kilowatt meter is a connect to the same server. It retrieves the data stored in the database for use as a reference in the algorithm process so that when all conditions are met, successfully connected to the access point, it is connected to the server. Seal data show connect, no indication of breach. Now we can see the flowchart, the Smart Seal, the kilowatt meter. Then the electronic kilowatt meter will supply electricity to the load with the relay in the energized position. If the applied conditions are not met, the power supply to the load will be cut off and the relay will be unpowered. All our algorithms from integration, current reading, and power calculation to send the acquired data to the server and handled by microcontroller. On the Smart Seal, there's a micro switch that functions as a switch that will activate the microcontroller automatically when the cable is disconnected or open, and the microcontroller will connect to the access point to send disconnected data to the server. The store in the database and rectify for use to the kilowatt meter algorithm to determine condition operational or not. This is illustration. There are two kilowatt meters. The first kilowatt meter is the all seal, while the only kilowatt meter has an integrated smart seal. If the seal is broken or open, the seal will send data to server and communicate with the kilowatt meter to break the load current. We can see the website or smart seal, where the place position in the case of tracking or opening. The result of the test of sending smart seal data with disconnected condition using the post method show that out of the 1,000 attempts to send data with the size of the data transmit, which is the 283 bytes, the maximum time needed by the server to process request sent is 328 milliseconds. The fastest the time the server required to process the send request is 69 milliseconds, with the average response time of the entire transfer time being 100.52 milliseconds. The result of the Smart Seal data delivered test with the broken seal condition using the GET method show that average data transmission from the server is 358 bytes. The longest time it takes the server to send data from the server and encode data to device is 267 milliseconds. And the fast time required to send and encode data from the server to the device is 70 milliseconds, with the overall average time need to process, encode, transfer, and be received by the device 102.39 milliseconds. The test result for sending the kilohour metadata using the POST method are 283 bytes. The platform takes the longest time to process data sent for 315 milliseconds, and the first time for processing data by the platform is 63 milliseconds, with the average overall response time of the platform is processing data is 107.8 milliseconds. The result of the testing request for meta condition data using the GET method show that the platform handled incoming requests for the longest 238 milliseconds and the fastest for 66 milliseconds. The average overall time required for the server to process and return the response in the form data to device is 100.61 milliseconds. The platform gave a very good response from the comprehensive test to send data, the POST and GET method to the server. The result of the Smart Seal test showed that the average times required to connect to the access point is 579.56 milliseconds, and the average time to send data to the server to process data is 161.68 milliseconds. The test was carried out the access point connect to many devices and very slow bandwidth of the 32 kilobyte PS, but because the data transfer is a very small byte, it's not affect the platform performance. The result of the test include the Smart Seal and a kilohour meter work very responsively to the treatment given and can send data on the condition the broken seal to the server very quickly without the failure during the delivery process, so it can be said to have very high level reliability. The kilowatt-hour meter test is done by comparing reading of the kilowatt meter with the standard multifunction calibrator with the average error of plus minus 5% at a current of 109 ampere with the correlation coefficient of the 0.9777. It can be seen the prototype kilowatt meter can show reading that match the current input. Program looping code with the will compile first until the kilowatt meter prototype condition requests data for seal condition to the server. However, in this case, it does not affect the functionality of the kilowatt meter and Smart Seal in performing integration because the seal condition data has recorded in the server database. The program code sequence must be complete first to achieve the disconnected mechanism. We can see their website for monitoring integration for Smart Seal and kilowatt-hour meter. This is administrator and user. Okay, conclusion. Integrating the kilowatt meter and Smart Seal use an AP platform that function reliably on every request and send data with a 100% 100% success rate. The current indication error on the kilowatt meter plus minus 5%. The time required to transmit the data for the post method has average overall response time of less than 400 milliseconds in the processing data sent to the server, and average response time for data transmission for the GET method which send data from the server to the prototype is 100 milliseconds. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you. Then we go to the question and answer. Is there any question from the audiences?
May I?
Oh yeah, okay, please.
I'd like to ask how many chance are your system will be integrated into PLN?
Sorry, pardon, this here rain. I don't hear.
What are the chances of your proposal to be integrated into formal KWH meter from PLN?
This is different prototype. Kilowatt meter, our government and our PLN until Smart Seal, our two government. So different platform. So this my research. I want to integrate between meteorology and PLN, right? And I will to not yet to give the proposal PLN next time maybe.
Yeah, we hope so, because the application is quite interesting. Therefore, you don't need any electrical officer to check the meter.
Yes,
it do it
yes,
automatically.
Yes, this kilowatt meter two-way, and now that we use the token kilowatt meter, 12 number token. Right.
Okay, I hope you success and have a further
Thank you
collaboration with our electrical company. Yeah,
okay.
with government.
Thank you. Yeah,
Thank you, Bu
very much.
Irawati. Okay. Yeah, Bapak Ibu, we continue to the fifth presenter, Ibu Diana Novriani, ABS 29, with entitled Early Warning System for the Fire Catcher in Rainforest of Sumatra. Okay.
Okay. Should I play the record or the PIC?
We will do it for you.
Good afternoon, ladies and gentlemen. Welcome to State University of Jakarta. I'm here to present our research titled Early Warning System for Fire Catcher in Rainforest of Sumatra. This research was conducted by Diana Novriani, Dr. Mutia Delina, and Amanda Muhammad Rizky. The phenomenon of this research are the use of forest land as the fulfillment of the people's economic needs mostly occurs due to changes in population characteristics and weak institutional control factors in monitoring forest land tenure activities for agriculture. Data obtained from Sipani in Sumatra. Losses due to failure of forecasting and early detection due to forest fires are estimated to endanger 36,000 lives per year between 2020 until 2029 if fire disasters due to forest expansion continue to occur. Controlling due to forest fire is deemed necessary to utilize satellite technology prior to the occurrences of fires. But the technology is still at the monitoring level and has not yet entered the prediction level, which allows for a fairly long pre-production timeline. State of the art of this research, the study uses this early warning system model method, which is formed from geographic and hotspots data at the Jambi Province Forestry Service. The research was conducted using a geographic information system model, which is an information system as spatial data and non-spatial data based on space and can be used in a decision-making process. In this geographic information system, the information retrieval process starts from storing, manipulating, and analyzing geographic information based on location. Problem formulation for the first year of this research are how is geographic information data management for the geographic information system, and then how is the hotspot data management of geographic information system hotspot, and how can model prediction of hotspot movement information detect fires when the climate becomes extremely due to climate change. The research purposes of this research the study is expected to predict information about forest fire patterns in Sumatra. This research is expected to be able to create an early warning system model to detect hotspots during the forest fires. And this research is expected to create a model of geographic information system that can be used to prevent forest fires from occurring during extreme climate. The research implication model flow chart was known in Indonesia in 1972 as database for development by Purnadipta. And the advancement of GIS system communicating has the GIS communication flow model, namely geographic model selection, database concept design, conception of GIS analysis, and user conception. This is the flow chart of GIS communication model. The research framework of this research starts by gathering data and then data pre-processing, database clustering, and then submitting in cluster analysis data, and then cluster evaluation, and cluster of visualization, and then the implement of system, and then the system end. Data gathering of the project of the framework are hotspots in parts of Sumatra and Kalimantan in the period 7 and 7 July 2009 by DINASA or MODIS rapid response image. And then forest fire hotspots in nearest Jambi Province Riau, Indonesia in 2014 and 2018 year term. The outcome of the research, the step is done by designing a system model. The outputs obtained from the visualization research will be connecting relationships with the application dashboard, so that it can easily understand and make it easier to be the design is directed to a system designer. In designing the early warning models is software. System design is solving complementary problems by assembling component parts into an integrated system. In building the information system model of the Jambi Provincial Forestry Service using the SQL-based with offline method with the following procedure sequenced by Yogi 2020. A. Designing the system architecture by making the initial system architecture. B. Building a user interface display by designing an interface so that the system can operate according to user needs. C. Database design by making the database field so that the data can be organized in a good and safe repository. B. Building a program with a program code design using PHP coding logic, and then implementing the system by testing and assuring the operation of the system into a model as desired by users. This is a database of early warning system for fire capture, accommodated and recorded by the dashboard of early warning system. The research results and discussion. Research results. Based on the research conducted at the Jambi Provincial Forestry Service, the results and detailed discussions are as follows. The frequent occurrence of forest fires during 2015-2019 in the rainforests of Jammu province and the surrounding area due to the undetected hotspots is an early indication of intervention on forest fire disasters. And there has never been any kind of information media about mapping this data. So the author provides a solution to overcome these problems in the utilization of an information system model, namely the geographically based early warning system for fire capture model using website access and offline data processing using NASA's Earth data database. By utilizing the offline websites, users can help to get complete information about hotspots and early indications of forest fire spreading in the rainforest of Jammu province. After conducting the research process on designing an early warning system model using a geographic information system, the research results can be explained as follows. The structure of the early warning system for fire capture model is an illustration of how a GIS application is formed and what features from the structure of the GIS model, what you need to know first is the GIS communication architectural model. Because with this model, it will be seen who the structural needs of each user are. GIS communication flow architecture as one in figure 3.2.6.1. In accordance with the communication architecture, it can be seen how the communication patterns in GIS model early warning system in data processing. The data process in GIS model consists of spatial and non-spatial data. The spatial data is the location data of the rainforest coordinates, while the non-spatial data attributes used are on climate change and weather in Jammu province. By utilizing the website model early warning system, you certainly help to get complete information about hotspots in the Jammu rainforest as a solution to the problem of detecting hotspots for forest fires for the Jammu provincial government. Conclusion of this research activity are the implementation of the early warning system model for mapping forest hotspots in Jammu province using NASA data for mapping in GIS was achieved by testing the application prototype on an offline website at the Forestry Service location. The early warning system for fire capture method aims to find ways to detect hotspots in the rainforest of Jammu province in the first year of conducting the research. Recommendation of the research, the implementation of early warning system for fire capture model widely so that it can be accessed by the public and the Indonesian government using a web browser for hotspot data as an early indication of forest fires can be carried out in the second year of this research. The author hopes that the research of the implementation of the early warning system for fire capture model can be useful for the wider community and can be published more widely using scopes in its international journals, so that technological developments through this research become more reliable and accurate for the work of science and technology 4.0. Ladies and gentlemen, I would like to acknowledge our research article in honoring of our alma mater, State University of Jakarta, and then Faculty of Economics and Faculty of Natural Sciences as the coordinator of this research. Ladies and gentlemen, I would like to thank you for your attention, and I'll see you later in another discussion. Thank you very much.
Thank you. Then we are proceed to the question and answer. Is there any question from all of you for Ibu Diana? I have a question actually, Ibu Diana. How many percent is the error of this program, and how to detect the false alarm?
First of all, the error of this application is limited to just only 10%, just because the actual data is somewhere along the border of Jambi Forest and South Sumatra Forest. We have to pick up the data from it and then implement into the system. That is all.
But it took time, right? And how to detect the false error somehow.
That's it. We have to input the data in the borderline of Jambi with any other region in Sumatra, and then the hotspots will be detected once we input the data. So we have to go into the Jambi forest borderline and then input the data directly.
Okay, so my conclusion that the data is not provided automatically from the forest, but we have to input.
That is correct. Because the purpose of this research in the first year of the research is to design the model of the fire catcher in Jambi Forest. And the second year will be online, and then there is to implement the NASA data in data, and then we will collaborate and then gathering the data, and then the output automatically with no errors whatsoever.
Okay, so this year is settling the algorithm for the program. Thank you,
Yes.
Bu Diana, for your presentation, and success for the future program.
Okay, you too, ma'am.
Thank you.
Yes.
Bapak dan Ibu, actually we have the sixth presenter, Ibu Elisa Sabila, a District 31 with the entitled Development of Research Study at the Faculty of Mathematics and Natural Sciences, State University of Jakarta, Indonesia. But he cannot come today, so we are going forward to the seventh presenter, Muhammad Eka Suryana, ABS 67, Architecture of Assistive Fish Farming Application to Boost the Harvest in the Intensive Culture System. Pak Eka Suryana, are you with us?
Yeah, may I start the presentation?
You may start your presentation directly, please.
Thank you. Request permission to share screen. Sorry. Okay. Thank you, fellow researchers, students, and lecturers from Indonesia, since I don't see anyone from foreign countries. In this session, I'll present my proposal to solve surrounding problems regarding the assistive aquaculture management system. This is some slight adjustment to the title which I submit to the abstract. Apologize for the inconvenience. Okay, so this is I'll review some little about state of the art. Particularly, there are three proposals which solve the aquaculture problem. The first one regarding the automatic filter hour machine. The second one about IoT real-time monitoring water quality system. And the third one regarding the aquaculture trading platform. But if we ask ourselves, actually, do this research needed by the farmer around us? If not, what actually the farmer needs? This is some conceptualization of the problem. You can see on the left image, there are two ponds. These ponds are similar in size. And then these ponds are filled with exactly same amount of fish. Let's say 1,000 in numbers. Then the question are, how many feeds are necessary to grow them until size of 4 fishes per 1 kilogram? Then based on the feeds given, determine the minimum trade cost such that the farmer take no loss during trading. And the final one, is it guaranteed given the exactly same feed amounts to both ponds? Since the amount of the fish are the same, will they be harvested? Will they be harvested in the same kilogram? The answer to the final question is definite no. This is some particular theoretical problem regarding feed to conversion ratio. Given 1 kilogram of feed protein, only about 1/3 that will become meat in the fish. That's a large discrepancy. Even this theory, when realizing in the field, came with large differences based on various situations. This is the question that will be answered by us. How to determine balanced trade price such that it profiting both the farmer and the trader. This is our solution. We design a system which supports the following primary features. The first one, tracking daily feeds given per ponds. The second one, tracking initial weight of fish inserted into a pond, since at the harvest time, we measure the growth size of the fish compared to the weight when it put into the ponds initially. And the last one, periodic weight grading per ponds through sampling. This is the daily activities which the farmer done for each day. So basically, they just need to insert this data into our application, and some extra features that will help the farmer throughout various problems regarding the tracking of mortality per pond, which happen for a particular day, tracking fish sorting per pond, since the fish in some occasion need to be moved from ponds per ponds. And the third one, tracking daily water quality. Basically, all this previous research, which conduct automatically through the system, is manually inserted into our application. That's our solution. And how we do that exactly, how we develop the system. We divide the development into two phases. The first phase, we develop the backend. The backend is developed with Flash micro framework and MongoDB database, while the front end, which will be displayed on the our computer screen or mobile device, will be developed with native Android software development kit and Flutter SDK, which will be ported to various platforms such as iOS including. Basically, we chose this architecture since we designed them to be AI integrated in the future. This is our state of development, which finished right now. The backend core architecture is completed. The native Android application is in development in parallel, and multiple platform Flutter-based application is in development in parallel. And the second iteration of application, which integrate multi-users to the platform, is now in development. So we conduct multiple development in a similar time. You can see our progress in these links. We put our whole source code into GitHub. You can check it if you want. But our code is licensed under GNU GPL license version 3. In case you use our code, you need to share it back. The second one, with our developed architecture are to be put into this link. You can see we've completed the web service, which will communicate with the front end devices, and also the documentation. This is the future application will look like. Currently, this is just a mock-up, since our proposal at this time only accommodate the back end. Yeah, but you can see this will how the application on the mobile devices will look like. And for the methodologies, we develop our system with Scrum methodologies. You can see this is the example. We completed the whole 10 sprint until the product is completed. The left images are the database scheme during the initial sprint, whereas you can compare that during the final sprint, the database became much more complex. This is intended since we develop the application iteration by iteration. This is some interface that that are displayed on the admin panel. This has been integrated into backend system. Basically, no application can run individually. When we see an application such as any application our mobile device, actually they are integrated, they are communicated with the backend, and it's the backend that will manage all the data that came to the application, not the front end. The front end just accommodate data which directly related to the user, not the whole application, not the whole system. Restatement, the final primary features that reported in our system is the feed conversion ratio. It will be then later be converted into minimum trading price, assuming we are we were given such as 1 ton of feeds. It must be minimum price according to the costs that are paid to the feeds, and we can report this data per pond and per harvest season, such that any farmer that will use our application can see it and use it as a reference when negotiated with the trader. Conclusion, I estimated, although it's not been tested on any real farmer since the front end still in development, this will bring large economic impact in aquaculture chain system if applied thoroughly, since the price that usually attached to the harvest product will be automatically judged by the system, not by the trader. Thank you. That's my presentation for this session.
Thank you, Pak Eka. Bapak Ibu, is there any question for Pak Eka in this presentation? Pak Wahyu, please.
Yeah, I need your help to show my video, Bu Mutia.
I mean, do you have any question for Pak Eka?
Oh, no. I misunderstood. Sorry.
That's fine. Okay, we are still in a question and answer session.
Okay.
Pak
Sorry.
Wahyu, do you have any question?
No. I think it's very clear. Yeah, thank you.
Okay, thank you, Bu Hani. Okay, I have one question for Pak Eka. So you will what they said, create your own market then. You cannot follow the market as usual, because somehow the demand will be depend on the market need. I mean, the price will not only influenced by the process, but also the demand of the market, Pak Eka.
May I answer your question?
Of course, you have to.
Actually, the product price is not set by the demand. During August inflation report by our government, any agriculture product receive a push from the top to lower the price. Just a few moments after the report came, the price inflated to the previous price. What we propose, we will renegotiate the price, the market price according to the system, such that it can no longer be manipulated. That's the thing.
Okay, I guess I give a wrong question to you because we have to discuss about the program, right? My mistake, I'm sorry. So can you show us the flow chart of the program? Because we love to find the process of your program development.
Okay, please allow me to share some process of the program development. Actually, since we're using Scrum, our application is not developed from top to down. Our application is developed iteration by iteration, and you can see the whole report.
Do you get any problem with the program? We cannot hear your voice.
Yeah.
Yeah. Okay.
You can see on this database diagram.
Okay.
We put our record during sprint 5. The database in this space have several tables, whereas when you switch it to the different sprint, we push it into several branch. It became more significantly complex. The whole report of the process of discretion will be reported in our full paper. May your attendant be patient. I cannot report the whole process here. Thank you.
Thank you, Pak Eka, for your brief explanation. I'd love to read your paper later then. Okay, yeah. Thank you, Pak Eka, Muhammad Eka Suryana from Universitas Negeri Jakarta for the agricultural intensive-based farming. It's quite interesting, and I hope it will help the farmer to have their right to have the right price. Thank you, Pak Eka. And then we continue. We go forward to Pak Wahyu Hidayat, ABS 68, and the end title of his paper is processing in noisy data of array sensor to enhance pattern recognition and classification problem. The time is yours, Pak Wahyu. We will see your video.
Good afternoon, everybody. Welcome to my presentation. My name is Wahyu Hidayat, and my colleague Dr. Agus Suroso will report our research. We are member of Theoretical High Energy Physics Division, Faculty of Mathematics and Natural Sciences, or FMIPA ITB. Today, I would like to talk to you pre-processing in noisy data of sensor array to enhance pattern recognition and classification problem. Our research focused on the impact of the data pre-processing to improve data quality for classification and pattern recognition purposes. We propose the use of a combination statistical method and artificial neural networks, or ENN, to recognize data containing noise. So, in this presentation, we use a data treatment to enhance the quality of the data. This is the keywords of our presentation: noisy data, governing equation, array sensor, and ANN. In my presentation, I will focus on 4 major issues as outline of presentation. First of all, I would like to give you an introduction of sensor array and how the data collected. Next, I will focus on method to describe experimental setup and how the data will be processed. And then we saw the result and also discussion. Finally, I will make conclusion. Let's start with introduction. In here, I describe sensor array, commercial electronic nose or CIRA-NOS, and introduce our problem in research, that is flavor classification. So in this work, I will try to distinguish orange, vanilla, banana, pandanus, and strawberry. Electronic nose or eNOS is an electronic device based on chemical sensor array that have a function like the human nose. This figure comparing the mechanism of human nose and the electronic nose. We also know that's why the human nose can detect the odor, because the human nose have sensor array 10^7 cell of 100 different receptor type. So this is the mechanism of human nose. And if we develop electronic nose, we imitate the process of human nose using the sensor and and of course the computer to process the data. This is a picture of 7-order detection process. On the left side is the mammalian nose, while on the right side is the electronic nose. In our experiment, we use a commercial electronic nose, namely CIRA-NOS 320, which has 32 carbon black organic polymer composite sensor. This CIRA-NOS has a benefit respond to a wide range of organic vapor and also has a response time of 10 seconds and can be operated at room temperature. And in this equipment also have a software to analyze the data. In this electronic nose has a sensor array that have 32 sensors. In this section, I will explain the method both experimentally and data processing. This figure shows you the process of measuring the aroma of the orange, vanilla, banana, pandanus, strawberry flavor. The red arrow shows the flow of the aroma from the bottle containing the sample, while the blue arrow shows the sensor cleaning process is carried out every time the sample change. The measurement is based on the change of resistance of each chemical sensor in 32 sensor nose chip when exposed to a chemical vapor. Sensor response through the A baseline pulse, and B is when the sample exposure, and C is when the sensor repress. This experimental setup for identifying aroma of flavor, we use CIRA-NOS 320 is used to identify and collect flavor data. We put 13 drops or 0.65 milliliter for each bottle. We have 5 flavor: orange, vanilla, banana, pandanus, and strawberry. All of these vial or bottle will be smelled by CIRA-NOS. This table shows you the result of our experiment. This is the row of the data. This is the diagram how the data will be processed. Data generated by the sensor will be taken to the first. We should pre-process the data by centering and scaling. After that, we send to algorithm of neural networks. We use 32 input and 12 neuron in hidden layer. And also we have 6 output node in output layer. In this section, I will give you some result and make a discussion. This is the Ceranos 32.0 and result. We got result by principal component analysis or PCA of Ceranos software. PCA projection plot of 5 flavor, aroma of flavor, pandanus, vanilla, banana, strawberry, and orange, and also one sample of background air. We see that the figure that the sample cannot be reliably distinguished. Despite that, our experiment did not give information about discrimination of different kind of flavor by using Ceranos algorithm. So we need extended algorithm that can be trained to know pattern of the data. In this research, we developed artificial neural network to make it clear. This table is the result of sample identification by using Ceranos 32.0. This table gives information that our background was contaminated by a stronger aroma of flavor. For example, in this table is strawberry and orange. The number of star in parentheses here is the identification of rating. A 5-star rating is the best, and a rating of no star is the lowest. After repeat 3 times, the Ceranos can predict all of the sample. But we have a problem here. The Ceranos can detect strongly strawberry, banana, but ambigu to predict orange, vanilla, and pandanus using Ceranos software. Because there are several limitations of the Ceranos software, and then we use Ceranos is only for collecting data, while the processing is done using a computer. After we collect the data, we make a treatment. We got 32 raw and 1,140 size of matrix data for experiment. We use backpropagation with Liefenberg-Marquardt training algorithm was used to train artificial neural network input. We also set parameter 0.1 for learning rate and 1,500 maximum epoch. We stop training process if epoch reach maximum epoch or mean square error was equal 0.00001. We also normalize input data to get data, which means 0 and standard deviation 1. This is our simulation result. The simulation result were produced by artificial neural network after training a chip 8.8x16 multiply 10 to the power minus 6 mean square error with 43 epochs. Our simulation also show that after training of artificial neural networks, there is a pitting blue line is plotting target. It means the data of training. And then the red line is the output of ANN. So the training of artificial neural network so successfully in this figure. If we calculate the percentage of target and output artificial neural network by the formula target data T minus output artificial neural network O multiply 100%, we saw the fluctuation of error. This is the percentage of how similar target using data training and the output, the numerical result of artificial neural network. To test artificial neural network reliability in predicting, we predict data classification that have never been used when training artificial neural network. So we get 60 data and never been used in artificial neural network training, but for predicting only. So the output of artificial neural network from background error data, we see that the output of NN give us 1 for background and also orange for other, but 0 for other example. This figure is mean our work described that the cause of experimental was not done properly. Background air was contaminated by stronger aroma of flavor, that is orange. But after we make a treatment of pre-processing the data, we also get the right side of this figure. Our NN successfully to predict pandanus and also successful to predict banana, orange, and also strawberry and vanilla. Finally, conclusion. The important thing should be done in experiment to get clean interpretation of sensor responses. Drying air and some control background condition give significant results. Our work described that the cause of the experiment was not done properly. Background air was contaminated by strong aroma of flavor, that is orange. Then we get noisy data and difficult to recognize by basic algorithm. We improve, use baseline manipulation and statistical treatment. Then by using artificial neural network, we also prove the successful of data prediction. If you have any question, I am happy to answer them. Thank you.
Thank you. Interesting presentation, Pak Wahyu. So here we find out how the sensor program learn to taste some flavor. Is there any question from the audiences? Okay, Hani.
Okay. My question is, based on your presentation, why you have to apply 32 sensor and what is the application of this program in the future?
Can I answer directly, Bu
Yes,
Mutia?
please, Pak Wahyu. The time is yours.
Yeah, yeah. Because based on my experiment, I use 32 sensor array based on collected data in experiment. We get 32 sensor from commercial electronic nose. Of course, next time we should select the reliability, sensitivity, and reproducibility of the sensor. If the sensor has a problem or give very much noisy data, but in here for preliminary experiment, we use all of the sensor because we have 32 sensor. So the input of artificial neural network, we use also 32 input. Thank you.
Okay, is it mean that the temperature sensor is given from the factory?
Yeah.
Okay, yeah. And the application, have you answered the application of this program in the future?
Yeah. This is a very wide application in research. The electronic nose, if we hear about electronics produced by UGM, Universitas Gadjah Mada, we know GNOS can detect qualitatively about virus corona. If we also here in foreign country, we also use electronic nose for detection of PNT, exploded chemical. That is many application in the future works.
Okay.
Yeah.
Thank you, Pak Wahyu. Interesting. Thank you for your time, Pak Wahyu Hidayat, and success for the following experiment. And Bapak dan Ibu, we are going to the last presenter, Ibu Sally Anastasia Amelia, ABS 104. Ibu Sally will present a systematic literature review to evaluate the impact of machine learning and artificial intelligence for lung cancer patients in COVID-19 pandemic. As we know that the COVID-19 pandemic can cause TBC and then lung cancer as well. The time is yours, Bu Sally. Thank you, and you have 10 minutes.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Today I will represent my team for present our research. The title of our research is The Urgency of Using Machine Learning and Artificial Intelligence for Lung Cancer Patients in COVID-19 Pandemic. Our team consists of me, Sally Anastasia Amelkaris, and Mr. Fauzan Izzapazar from Universitas Terbuka, and Mr. Arman Haki Anazili from Universitas Indonesia. Today, I will explain from the introduction until conclusion. So let's go to the introduction. COVID-19 was first identified in late 2019 in Wuhan, China. Dry cough, fever, shortness of breath, headache, and pneumonia are some of the signs and symptoms of COVID-19. Attack of this disease can cause progressive respiratory failure and even death. One of the most worrying things about COVID-19 is the presence of comorbidities. Many things are associated with comorbidities, including poorer health outcome, more complicated clinical management, and high cost of care. Several metadata analysis suggest the prevalence of comorbidities in COVID-19 patients. The data also show the parents with comorbidities such as heart disease, lung disease, diabetes, and hypertension who are affected by COVID-19 are particularly vulnerable to the general population. Comorbidities make a person's immunity weak, and people with weak immune system have a more dangerous risk of being infected with COVID-19. Cancer is a disease that affects the immune system. According to study, COVID-19 raises cancer patient risk complication and mortality. The risk of dying from COVID-19 is 3 times higher for cancer patients than for the general population. A study utilizing COVID-19 was done on 105 cancer patients and 536 non-cancer individuals. There is also a higher mortality rate in cancer patients, one of which is lung cancer. Unfortunately, there are many long steps that need to be taken to detect lung cancer. Additionally, it takes a long time to detection lung cancer and need experts and specialists to detect it. Time by time, lung cancer detection is done using machine learning and artificial intelligence. Machine learning is one of the methods of artificial intelligence by imitating human intelligence to solve a problem. The way machine learning works is to develop machine learning capabilities from a given dataset and provide useful insight for those who use it. A computer's ability to replicate intelligent behavior with the least amount of human intervention is referred to as artificial intelligence. There are many challenges and difficulties regarding cancer patients and the treatment posed by COVID-19. Unfortunately, the available data regarding lung cancer patients during the pandemic is still very limited. Therefore, there is a need for elaboration of previously cited article. The article were identified by the systematic literature review, or we can say SLR method. By using the SLR method, it is expected to achieve the desired result and gain insight from the article to be interpreted. So we are going to the next, the methods. For this study, we're using systematic literature review, or SLR, and there are 3 questions about this study. A research question. First research question is, how many articles on SLR have been published for lung cancer patients in COVID-19 pandemic from 2020 to 2022? Second, what percentage of the article on lung cancer diagnosis are based on machine learning and artificial intelligence from 2020 to 2022? And third is, what urgency of machine learning and artificial intelligence are used to detect and use in treatment for lung cancer in COVID-19 pandemic? And the inclusion criteria set in the study were, first is a study about lung cancer during the COVID-19 pandemic using machine learning and artificial intelligence. Second, a study conducted in 2020 till 2022. And third is not a literature study, narrative review, systematic literature review, and meta-analysis. For this study, we search using the keywords COVID-19 lung cancer machine learning artificial intelligence from Google Scholar, PubMed, and Science Direct. And here the prisma of our research. First, our research article have been identified through a literature search with the keyword COVID-19 lung cancer machine learning artificial intelligence in PubMed, Social Direct, and the Google Scholar, and there are 15,330 articles about it. After that, we make elimination from the article. The same research archive or duplicate were selected and removed, and there are 13,903 articles. After that, we screening related to research content was carried out by looking at the research abstract that we remove archive number is 13,857, which is literature review 3,120, and different research subject and notable articles 10,737. After that, we find the research related to full text article was conducted, and there are 46 articles about it. So we inclusive study related to the application of artificial intelligence and machine learning in lung cancer patient during the COVID-19 period. And here the result and discussion. Numerous studies that have been published use diverse techniques and data input to identify lung cancer. Chest X-ray and CT scan picture are used as input data in certain study, while other study employ patient character and health information data as a picture for the classification procedure. The technique employed range from the stakeholder classification technique like supervector machine or SPM to using a neural network for the detection procedure. This research main goal can be broadly classified into 2 categories for detection, depending on the input data they have. Some attempt to predict which lung patient will survive or not, while others try to determine which patient have lung cancer or which not. During the COVID-19 pandemic, research on the application of artificial intelligence and machine learning for the identification of lung cancer is facing new difficulties. First, most health research are devoted on fighting COVID-19. Leaving new research available to treat individuals with lung cancer, despite the fact that early detection of lung cancer is crucial from treatment before the disease worsens. The second issue arises in studies that use image-based input data. It is well known that it's very difficult to distinguish between side effects of the healing process, immunotherapy, and radiotherapy for patients with lung cancer, and effect of COVID-19 based on the character of chest X-ray or CT scan picture. As a result, starting the 2020, Up till the present, there have been numerous studies that concentrate on utilizing artificial intelligence and machine learning to categorize COVID-19 patient as either lung cancer patient or not be based on input data. Some problem in medical research may not have been able to identify lung cancer early in pre-COVID-19 pandemic. For the accurate diagnosis of COVID-19 related illness and lung cancer, early detection and high processes are essential. Given the data being researched may not be balanced, the success criteria employed and accuracy is not a necessary requirement. And here, the conclusion of this research, time by time, lung cancer detection is done using machine learning and artificial intelligence. However, there are no studies that show difference between people with COVID-19 and lung cancer. Further research is needed using various data to be able to separate patients with COVID-19 and lung cancer more quickly using artificial intelligence so that the treatment carried out can be precise and optimal. And this is our presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Bu Sally. Quite interesting because I have a sister which get effect of COVID-19 as well, but he got the tuberculosis, not a cancer. Okay, Bapak dan Ibu, is there any question for Ibu Sally?
I have.
Okay, Pak Eka, please go on.
Madam Sally, may you go to the flow chart which show how you conduct the systematic review process?
Wait a minute, because I must open my presentation first.
Can you display it, or I just need the flow chart for this discussion?
Yeah, he will prepare for you because the previous one is video from the organization, from the committee. Do you need us to show the video, Bu Sally, or you find your file?
Maybe I can find the article.
Okay.
Okay, may I share screen?
Yes, please.
Madam Lydia. Okay. This is our article, Mr. Eka.
Yeah, okay, thank you. I see it. On the second box, you cut, on the third box, you cut the number of the review article from some 13,000 to just 46. And you state in the statement, you do this by screening the article manually. How you do that? Do you actually screen them by yourself, or you just filter them, which are provided by the system? Thank you.
Okay, thank you, Mr. Eka. I just read the abstract because the articles, there are 13,903 articles about lung cancer, machine learning, artificial intelligence, but not all article is about the content we need. So we must find the content, the lung cancer, medicine, learning, artificial intelligence in our article. So we only have 46 because very difficult to us to find the article related with our subject and our research.
So did you read all the 13,000 articles? Since you state it, you look at the abstract.
I read the abstract because only and some article can we see from the abstract is related or not.
I confirm again. So did you actually read all the 13,000 abstract manually?
Yes.
That's a tremendous number.
This number is very big, but if we see from the first or the second sentences, we can see how relate the article with our research.
Yeah, somehow in the abstract we can find it out. Yeah, Sally, I
Yes,
agree with you.
we can see
may
in
I?
the
Pak Eka, we only have 1 more minute. I'm sorry.
Yeah. Last question, please. How many hours you spend to filter them out in the abstract?
Please lower down your voice. You look like an angry person
Oh,
here.
sorry.
Yes, I like some months. Actually, I have two research, and this is our first research for make a program, and we see. I know what is your confused with. There are 13,103 articles, but only 46. And how long our team to find this article? So for us, for our team, we need some months for read, and we not only find the abstract, but we can see from 1 or 2 sentences in the abstract is related or not, because we can see the point from the research from 1 or 2 sentence. Because many research in 3,903 not related with our research.
Okay, is it clear, Pak Eka?
Thank you.
Thank you, Pak Eka and Bu Sally. Interesting. I hope that your recommendation from the literature review will proceed to the new program, because we need to identify the lung cancer as well as COVID-19. Thank you, Bu Sally. And Bapak and Ibu, this is the end of our session. I would like to read some important information. Would you like to share it, Hani? Yeah. The first one, the certificate will be able to will be available on the registration system on September 9, 2022. And then the information of the best presenter, I hope one of you is the best presenter, will be able in the website on 9 September as well. And then don't forget, if you are interested, please upload your full paper to the register system. For the publication process, we have a proceeding with a Scopus index in AIP, and then the publication payment only paid when the paper has been accepted. So do not pay anything before your paper is accepted by the journal. I'm sorry, by the publisher. And then I love all of you to attend the closing ceremony of SMIC 2022, which will be conducted 3:45 p.m. this afternoon in the main room. I'm Mutia. I'm the host of this session. Thank you for your kind attention, and thank you for your presentation as well. And we love to see you in the next event. Assalamualaikum warahmatullahi wabarakatuh, and see you all of you. Have a nice day.